Good afternoon to everybody. Welcome to all the participants, the speakers, and the attendees. Welcome to this event, which has been organized within the framework of the Earth Day of this year 2022. This event has been organized by the CO2MPRISE. It is a project founded by the European Union, connected to a specific theme, a specific topic, which is the central in the day of today. The CO2 storage and conversion issues, which is not a big challenge, but the challenge of today for the scientific community and for all the people of the world. The control of the CO2 emissions and the possibility to develop new technologies related to its storage to the CO2 conversion is the big challenge that we face today, and for which a large part of the scientific community is addressing their efforts. So our project intended to focus these topics from a specific point of view. I mean, the group of scientists involved in this project are related with matter transformation. We are chemists, we are physicists, we are physicists, we are engineers, and all of us are interested in the CO2 transformation, CO2 storage, focusing in particular on the innovative materials and the processes related to the possible transformation. I will share with all of you just a few words, a few slides representing our project. Just a second. Okay. This is the picture representing the event of today. It will our meeting will have the format of a round table at which in which the speakers will be the leaders of the different research groups taking part to our CO2MPRISE project. And the title is the title that I was citing a minute before. Our project, as was saying, has this title, which means CO2 Absorbing Materials Project. It is a project which started a few years ago and includes research groups coming from Europe, at the University of Sassari, at the University of Burgos, the ICCRAM Research Center, in Germany at the Helmholtz Zentrum in Hereon. We have a company participating in our project, MONOLITHOS from Athens in Greece, and two universities, two research centers in South America, the University of Chile in Santiago, Chile, and the National Research Center for Atomic Energy in Santiago, in Bariloche in Argentina. Our focus is addressed to basic research in terms of chemistry of CO2 conversion, new materials, new process, new technologies, and also is addressed to develop new technologies starting from our research. And after 3 years almost 4 years of implementation of our projects, we are now approaching the last year of our project, and we would like to share among us and with all the attendees our feedback, the results of our project, our perspective, and with this in mind, I would like to discuss with all the present the results of our efforts. Of course, we will leave some time for possible questions arising from the attendees. We will be very happy to discuss also with all the people taking part to this meeting. I will stop my presentation now, and at this point I will leave the microphone to the other speakers taking part to this meeting, and I will start our conversation asking to my colleague Sebastiano Garroni
organize different seminars abroad in the different countries, in the different units, to realize the core of the project, that in fact is to include the opportunity for new perspective of career for the early stage research, but also for the experienced researchers that belong to this kind of action. Precisely in the specific, we realized, in my opinion, a very good job in the sense that we started with a few but concrete ideas about the materials to exploit in this project, and after that we start also to build a new technology, new process for trying to mitigate the one of the biggest problem up to date for our Earth, that is the increasing level of carbon dioxide emission, in the sense that we use, first of all, materials from the raw materials, as for example the olivine that was exploited not only by thermal but also by mechanical, so not classical way, by mechanical in particular, also by solar, to try to in the first part to absorb in the carbon dioxide, and after that to valorize the carbon dioxide. That is another point, because it's very important to create a virtuous cycle of carbon dioxide. In this sense, we obtain extraordinary results for producing light hydrocarbons that are very good new green vector if they are produced for carbon dioxide, for example, in order to pave the way for the transition towards the carbon-free world. Okay, for energy. The second point is regarding the new opportunities. Let me say that in particular for Sassari was a good opportunity, because we can strengthen new collaboration with the partners involved in the project, and we realize some specific outcomes regarding the carbon dioxide transformation into light hydrocarbons, and these results are also highlighted by the fact that we are now involved in a consortium for chemical reactivity, a national consortium for chemical reactivity that now is working 90% only on them regarding the carbon dioxide catalysis into transformation to added value and so on. So from many point of view, this project has been a very a great opportunity for UNIS partner, and let me say the new perspective regarding to exploit now these results. First thing to remember that we have to try to upscale our processes and, if possible, exploit also the lab scale that we have demonstrated during the last year. The results are published, but also there are patents included. So there are, I mean, it represents a new start this year, in my opinion. After the last 2 years are quite difficult from other points of view. By the way, it is a very good restart for exploiting our results, of course, with all the partners, and also try to think about the new calls inside the Horizon Europe program for trying to see if there is a new opportunity for us to create and create a new consortium for other actions. So from my side, this is my feedback. I take this opportunity again for asking for thanking to provide you my really thank you for this opportunity, in particular for me, because was really important to enjoy your within this project and in this particular action. Gabriele, the microphone, please.
So, sorry. Thank you, Sebastiano, for your answer, for your reply, and I would move to our colleague representing a company involved in our project. I would like to introduce you Iakovos Yakoumis, the founder and CEO of MONOLITHOS, a company operating in the specific field of CO2 related issues. Now I kindly ask to Iakovos to draw his focus in general, the focus of his company and his activity within our project, and what is his feeling, his feedback concerning the project, and the perspective at this stage of the project and looking to the future, to the future of CO2 related issues. Please, Iakovos.
Thank you, Gabriele. Thank you all. Here in Greece, we are experiencing Easter, so today is Holy Friday. And I'm very happy to be with you and discussing about compromise. If Gabriele could stop sharing your screen, I could provide a visualization of what you asked me about. I have a few slides. We don't hear you, Gabriele.
Okay, please. I will close my. And I will, so you will be able to go ahead.
Okay. In the meantime, I would like to say my experience about the COMPRISE project. We have a dual good thing from the project. First of all, we experienced something that it is not very common for companies, and this is the exchange of staff. Meaning we sent, and I hope you are seeing my screen now. Yes?
Yes, Iakovos.
Perfect.
Okay. So what I am writing here, this stuff exchange is priceless for us. Here you can see pictures of people coming and going from MONOLITHOS. You can see Alberto, Pierre, Stamatis to be in Burgos, and the two new people that they are in MONOLITHOS right now, Luca and Alessandro, experienced a second Easter this year. After the Catholic, now they have the Orthodox this weekend. And so we are very happy to host these people and to exchange information, ideas, and scientific excellence. This excellence resulted to two publications in collaboration with the University of Sassari and ICCRAM, for which we are very happy and very proud. And this happened before the COVID. Unfortunately, the project went in the COVID area, and some of the activities, the exchanges at least, were very difficult to happen between 2020 and 2021. However, for us, it opened us a new era and a new perspective in the company about the CO2 valorization and capture. So now we are, with the help of Alessandro, we are developing a new synthetic gas bench in order to be able to catalytically reduce CO2 to e-fuels, alcohols. We think that this is the fuel of the future and have a lot of applications, both in the automotive sector, in the stationary application, but they have a very big applications in the marine sector. So we are trying to apply our catalyst, because as a company we are developing and selling automotive catalyst for emission control. We have patented Prometheus low PGM catalyst, and this catalyst will be assessed in the application of CO2 reduction to e-fuels. However, as I told you, the project put us another way of thinking about CO2. So we started, and we, having in mind this, we started developing new devices in order that can be used in our applications, and having in the back of our head the CO2 reduction or capture. So in the last years, we have developed and patent and membrane, an electrochemical membrane. You see here how it works. It works by putting out from the flue gas emissions of diesel engines both carbon dioxide and oxygen. So it has two applications, two big applications for us. The first one, and it is obvious for our project, is the reduction of CO2 emissions, both for stationary and for vehicles. But the other, which is for the emission control, is that it put out from the flue gases the oxygen, so the catalyst can work better in a not very excess oxygen environment. So we published this the idea, and we have patented, and the European patent is pending this membrane. And the good thing is that we have upscaled this. So we have created a synthetic gas bench with a gas chromatographer that it is able to measure the separation of carbon dioxide and oxygen from flue gases. We have simulated the flue gases of a heavy-duty vehicle, and that's what, with this way we were able to make this kind of membranes in the full scale. And here you can see the full scale. You see full-scale devices having membranes of 25 centimeters. They have every device has 30 membranes of this kind of the specific kind. We have retrofitted until now five very old Euro 0 heavy-duty vehicles of a municipality here in Greece called Galachi. And with this kind of membranes and our catalyst, we were able to meet Euro 5. We upgraded this 20 years old garbage collectors from Euro 0 to Euro 5. And if you see there, the lambda is the oxygen content of the emissions. You see with the use of the membranes, we were able to put it from 15 to 4. So we reduced the lambda content by 70%. and we have been able to reduce 70% the carbon dioxide coming out from the flue gases too. So if you see in the line above, we were able to reduce the NOxes, the emissions of NOxes, due to the fact that the catalysts are working better, since the oxygen excess in the flue gases of the diesel engines is not very big. So this is our membrane for CO2 separation, while we are developing electrochemical catalysts for electrochemical production of e-fuels using electrolyzers. We are participating in a very big Green Deal project coordinated by DLR, the German Aerospace Authority, aiming in producing the first worldwide 1 megawatt direct electrolyzer of CO2 to e-fuels. What we are doing in this is that we are developing the catalyst. We are a catalytic company, so we are developing two kinds of catalysts in the scale of kilograms, a nickel ferric oxide catalyst and a cuprate catalyst, in order to be able to make the simultaneous, in one step, the CO2 reduction in the electrolyzer for producing liquid fuels. Here you can see our equipment for making this nano catalyst, and for characterizing this from the beginning of the project. We have developed an analytical laboratory right now. We have in-house XRF, ICP, gas chromatographers, and upscaled reactors from 1 liter to 150 liters. So we have the ability of developing and producing nano catalysts in build scale. Finally, the biggest problem of this kind of applications, so the reduction of CO2, is how you produce the hydrogen you need. And you need to produce the hydrogen in a way that it is sustainable and not by burning fuels. So the water electrolyzer technology, especially the PEM water electrolyzer technology, will be very getting more and more attention in the future for producing hydrogen, in order to use this hydrogen to reduce the carbon dioxide to e-fuels and methanol. We are developing electrocatalysts for this kind of applications, and because it's the Earth Day, what we have done is we were able, and I think it's the first time in the literature, that we were able to recycle the electrochemical catalyst of the PEM electrolyzers and fuel cells using our recycling technique. With this kind of recycling, again in upscaled processes, we have very high efficiency, meaning that we can take back more than 99% of the platinum and more or less 60% of the iridium of the electrocatalysts that they are used for PEM electrolysis of water. So we have published even the recycling approach, and we have submitted a Greek patent for the process, and we are waiting for the results. As I told you from the beginning, this involvement of monolithos in the CO2 utilization separation process begins with CO2MPRISE, and we are very happy for this, and we are very happy for the collaboration with the partners. So we would be interested, and we would be welcome you to find and see more opportunities for the future to continue this very nice collaboration. Thank you, Gabriele.
Well, thank you, Iakovos. So thank you for the overview of all of your work and the activities carried out within your company. It represents a very active, innovative companies within the European framework addressed to develop new technologies for a frontier issue like this. As a matter of fact, together with most of the experimental activities carried out by most of us, there is another specific topic concerning the modeling of these activities. And in our In our consortium, most of the activities are carried out by the group, which is led by Santiago Aparicio at the University of Burgos at the ICCRAM Institute, yes. And I would like to ask to Santiago what is his feeling with all the how experimental activities are going to be overlapping or interacting with the modeling activities, which is the mutual role of these 2 points of view in the development of new technologies, and what is his feeling for all this issue for the near future. Please, Santiago.
Hello, thank you, Gabriele. Well, as you have said, our role in this project has been to develop the multi-scale modeling of materials. So basically, we are a theoretical research group. But I have to say that one of the main advantages of this program, of this process, has been the collaboration both with experimentalists at the universities and also with companies, with MONOLITHOS. Several of our students, of our doctoral students, has been doing research or have been doing stays in MONOLITHOS and in other research centers with experimentalists and with company, and this has provided them a wider vision of the materials design, which is the role of their thesis project. So it has been very, very useful for beginning for us, for our students, because it has complemented their activities. They used to work with supercomputers, with mathematical models. So sometimes they are far from the reality. So it has been very useful for them to approach to the real world problems, to the commercial vision, which is provided by companies such as MONOLITHOS. So for them, this has been extremely useful. Regarding our research activities, so basically what we have done in this project is to develop multi-scale modeling of different kind of materials. Basically for validating and for designing our, let's say, theoretical method, the information obtained from the experimentalists, from the companies, in terms of their requirements, in terms of their needs, is fundamental. First of all, for considering which kind of materials are we going to target, and secondly, to see what kind of information can be obtained from our theoretical method, because we can carry out different types of modeling, we can predict different kind of properties, we can predict different things, but obviously what we try to provide is information which is useful for the final objective of the project, which is to have materials which are suitable for CO2 operation in terms of capture, storage, and conversion. So basically, this information which comes from the experimentalists and the companies has allowed us to improve our theoretical methodologies, to adapt them to the particular needs of these kind of materials, and to consider different kinds of materials. We have carried out studies, and we are developing studies starting from atomistic level to meso and macro scale. So basically, with different types of modelings, we can provide different information for designing different kind of materials. Our role has been double in this project. First of all, we are trying to understand the mechanisms of interaction of carbon dioxide with the different materials proposed, why these materials are able to capture in a more or less efficient way in terms of the chemical composition, in terms of their physical-chemical properties, any kind of information that we need. And secondly, we have developed methods for doing in silico design of materials. So what we want to do is to be able to propose different kind of materials theoretically in silico, to predict their properties, and to show their performance with regard to the objective, to the molecular objective, which is carbon dioxide. at the beginning, we start with the initial materials that were proposed in the project, like carbonates, like metal hydrides, this kind of materials that we firstly considered. But along the project, we have studied very, very different kind of materials. So we have studied from porous materials, covalent organic polymers, metal organic frameworks. We have studied two-dimensional materials. We have studied ionic liquids, and we have studied also dibutyric solvents. So we have studied very different types of materials, solid, liquids, membranes, and we have developed methods for analyzing their properties, for characterizing the behavior of CO2 with regard to these materials. And also we have gone beyond in terms of improving the properties of the materials, changing their chemical composition, seeing how these molecular changes or structural changes improve or not improve the characteristics of the materials. So we have been able to develop predictive methods in order to design and improve the properties of materials. Obviously, all these materials had to be tested at the end at the laboratory level, but we have been able to develop a collection of tools, a collection of predictive methods, a collection of physical or mathematical methods to design and analyze the properties of new materials, most of them not previously studied, design it ex novo for the project, with good affinity for CO2, with high selectivity, with different properties in terms of their final use. We have also studied not only the capture, the ability of materials for separating the CO2 or the flue gases, but also we have studied different catalysts for CO2 conversions to hydrocarbons and alcohols. And also we have studied also storage operations of CO2. For example, we have published a couple of papers for using the captured CO2 for enhanced oil recovery and enhanced gas recovery operations. So we are trying to cover the whole value chain of CO2, starting from the capture, the storage, and the possible use for different conversions to different target molecules. So I think that the information and the value added that can be obtained from in silico modeling, from the theoretical studies, in combination with experimental results provided by the other partners, and also with the, let's say, commercial and view from MONOLITHOS company, it closes the cycle. So it gives a complete vision of the problem, which is obviously a very, very complex project in terms of technology, in terms of economy. So we can give the physics, the chemistry, and all the related factors, which allow to provide new materials with this final objective, which is obviously one of the main scientific objectives in our days. So that's all from our side.
Thank you very much, Santiago. So we learned a lot of things during within this project. I mean that as we see, not only experimental activity, but without understanding and modeling and predicting what is expected to occur, but with the interaction between theoretical approach, modeling approach, and experimental activities, we learned and we were able to address our efforts toward a right direction, a proper direction, in selecting materials and selecting operating conditions and so on. So thank you again, Santiago. And I would move to another very important member of our consortium. I mean, our project involves not only European research centers, but also academic institutions operating in South America. Fabiana Gennari is the leader scientist of a research group operating at San Carlos de Bariloche in Argentina, at the National Atomic Center of Bariloche, and at the Instituto Balseiro, And I would like to ask her feeling about this project, the activity they developed at the research centers. And furthermore, another very important point, I mean, what about the specific activities supported also by the Argentinian government and organization, and the interaction between the activity, I mean, the interaction between a research center so far located from Europe and ourselves in within the umbrella of European Union, which covers all of us in a very efficient way, the RISE project and the RISE organization. Please, Fabiana.
Thank you, Gabriele, for the presentation. I will try to speak about our group. Our department is the Material Physicochemistry department, and we are working in carbon dioxide capture and also conversation. The idea is try to reuse the carbon dioxide and minimize the emission of this type of environmental gas with impact in the world. And for us, it was very important to be part of this consortium of this project, because in our group we have an important amount of students and different fellowship, PhD students, postdoctoral students, and young researchers. All of them have the opportunity to travel, to have different research activities in the group of this project in Europe. And for us it was important because there was a complement between different laboratories. All European partners receive our student or researcher, and in particular, we explore together some new techniques to allow the conversion of carbon dioxide. We try to explore mechanical and thermal conversion of carbon dioxide using hydride as a portable solid phase with hydrogen, and try to reuse in this way carbon dioxide to produce mainly methane, synthetic gas, natural gas. And this was one of the topics, and other the activities performed was the mechanical activation of not only a portable hydrogen source, but also the portable carbon dioxide source, with the expectation to convert also carbon dioxide. In this case, the idea was this solid phase with carbon dioxide is mainly obtained for the carbon dioxide capture from the air. Then is a way to capture and also to allow the conversion to different fossil fuel. And for the group, it was very important, this project, because it was an opportunity to access to different high-level group and to different techniques which are not available sometimes in our center. Our group have a very strong connection with the Instituto Balseiro from the University of Cuyo. Then, in general, all these activities was close with a publication or with some thesis which finished during the progress of the project.
Thank you very much, Fabiana. So another important point has been underlined, the strong collaboration among all the groups, which allowed to carry out many research, to exchange many students, many fellows who were able to move from one lab to the other. And this, of course, enriched all of our group, all of our knowledge about facilities available in the different groups. This has been very precious for all of us, as well as the possibilities to know what is the activities carried out in each at all the laboratories of the partner involved in our activities. We had the possibility to submit and to publish different papers, some patents were submitted, and we now, after 3 years of project, we know, as I said before, we know a lot of we gained a lot of knowledge about the chemical behavior of CO2 and about the possibilities to allow its transformation in different products. With among our partners a very large research center located in Europe, addressed to troubles, chemical and engineering troubles related to environment. And the next speaker, Claudio Pistidda, leads a group located at the Helmholtz Center in Gstaad, whose name is Hereon, is the name of the center changed, and probably in some documents of our project is still reported the old name, but the relevance of the center is very large, and Claudio gained a very important position within the European Union academic and research position. I mean that he has been addressed as European Union Climate Ambassador, taking into account all his knowledge and his activities carried out in different sectors of renewable energies and climate-related activities. Within this project, his activity was mainly addressed to evaluate the reactivity of specific chemical compounds, and I would like to ask him his feedback about this project, the activity which was able to carry out, and also the activity he's carrying out as a European Union Climate Ambassador. Please, Claudio.
So first of all, good afternoon, and thank you for giving me the opportunity to speak today here. So from our point of view, this project was the first project of this kind, or institute, that is the Hydrogen Technology Center. Actually, really normally deals with the development of material for storing hydrogen. So we are expert in metal hydrides. However, we didn't have a great knowledge in the field of CO2 storage and CO2 conversion. Thanks to the CO2MPRISE project, we acquired quite fast this knowledge, thanks to the opportunity of hosting a really well-known researcher and experienced researcher that could lead us step by step toward a knowledge that was missing. Moreover, we had also the great opportunity to send young scientists from our center to other institutions. In particular, we sent our researcher to the Centro Atómico of Bariloche in the group led by Professor Gennari, and also we sent our students to the University of Chile. So from our point of view, this project has been a great success. First of all, we acquired a really strong background on CO2 conversion and catalysis related to the CO2 hydrogenation. So that was already great. We strengthened, if not, we started and strengthened the collaboration with several partners, and we consider this as the basis for the work in the next years. For sure, the great work that we did with our colleague not only brought to a general enjoyment of our work here, but also we made the basis for the work in the future years. So we are super happy about that. Moreover, give us the opportunity to plan the follow-up project of the COMPRISE, trying to keep all together in the same boat to achieve a new excellent scientific results. So our plan is to continue. So this was a beginning of a long-lasting relation from our point of view. So we are really happy. Moreover, you mentioned that I act as a European Climate Pact ambassador. So actually, there is another colleague from us, that is Iakovos, that is also an European Climate Pact ambassador. No, but what does it mean exactly? So actually, you know that in 2019, the European Commission presented the European Green Deal. No, the European Green Deal is a plan for transforming the European community into a fair, healthy, sustainable, and prosperous society. No, so that is a great goal. However, this is not easy. No, so the European community can make for sure a plan, but how to achieve the goal of the plan? Well, the Climate Pact is a Commission initiative that aims at involving several different stakeholders and civil society into the plan. No, so it's trying to share the responsibility of achieving those ambitious goals together with the society and the stakeholders that are often the industry. So the role of the European Climate Pact ambassador is the one of spreading the verb of the European community and trying to communicate whatever good does the European community for our society to everyone. So, you know, normally we see the what happened at the European community is something like separate from us, no? But in reality, we all have the opportunity to contribute and to be useful to achieving a better society. So that is the role that I and people like me and Iakovos have in the European community. So we are kind of carrier of a message. No? So that is what we do. But from my point of view, and also from the point of view of the colleagues that were involved in the project, for us was an extremely successful project and allowed us to not only make important scientific contribution, but also to start a scientific relation that we hope will last very long.
Thank you very much, Claudio, and thank you to Iakovos and Claudio for their role and their activities in this specific field. Their activity is so many.
Gabriele, it's not possible to hear.
Sorry, I didn't open the microphone. Sorry. Thank you, Claudio, and thank you. I was saying thank you, Claudio, and thank you, Iakovos, for the precious activities with specific regard to their role as climate ambassador of the European Union. And so within our project, we have two representatives, one from the academic and the other one from the industrial point of view related to this specific focus. Well, so just summarizing, as you mainly I'm talking to the attendees, the activity is carried out by all the researchers and all the groups of the consortium have developed different have gained a lot of knowledge in terms of chemistry, in terms of new materials, in terms of processes related to CO2 conversion, and allowed also to strengthen interaction between companies, between research centers, between universities located in Europe, located in South America, looking around to and deepening these very important topics that we are treating, the CO2 conversion and storage and conversion. Considering the time, we, as we said at the beginning, we have sometimes 4 possible questions arising from the attendees, or otherwise from a few words by some of you who would like to add something after our after the speech of each of us. Please, if there are some questions from the attendees, I invite all of you to ask us. Sorry. If not, I would like to add a further question to Iakovos, who represented the member of the consortium near to the market. How do you believe? Do you think that the research under development within our consortium and outside and in many other research centers can develop in the near future new possibilities for being reach the market? I mean, do you believe that it will be quite easy for the results we are developing to find other possibilities founded by the European Union to reach the market level? I mean, do you believe that the European Union will offer will offer us proper condition to the technology transfer of all of our research group and many other research groups within Europe are developing now, and which can help to find a suitable solution for CO2 storage and conversion?
The truth is, Gabriele, that the processes that are under development, they are not in the position yet to be competitive to the commercial processes of other kind of fuels, for example, or other kind of valorization of CO2. Not our process, all the process, including the electrolyzing processes for producing hydrogen. We are talking about low selectivity and low efficiency from the catalyst until now, and this has to be very much improved in the future in order to be competitive. However, the very good news is that the European Union has at least the legislation prospect to put liquid fuels, e-fuels, in the market, meaning that legislation is coming for putting more and more e-fuels as a percentage in the fuels, in the liquid fuels that the gas station they are selling. So at the beginning they will start with 10%, and this is growing. That is why big companies like Stellantis has already started to research on the stability of this kind of fuels and to see if they can use them in their engines. So I think that the political issue is there. The European Union wants to fund this kind of application. However, we need to research more and to find more things to do because, as I told in the beginning, both in selectivity issues and in the catalytic efficiency, we are not in the position that, for example, the refineries are for fossil fuels. This is my perspective in the market. May I make a question to Alberto, if he's here? Because Alberto is one of the
oh, please go ahead.
The former students. Now he's a PhD holder. I would like to ask him his experience because he spent a lot of time in us and in other places in the project and in conferences and workshops. So I would like to know from the first hand if he thinks that all this journey has made him better in order for his academic background.
Yes. Hi. Good morning to everyone. Well, yes, of course. I think that this experience for me was really wonderful in terms of that I can learn a lot of different things because, yes, as Santiago told me and told to you, this was my first step because I was doing my PhD related with theoretical tools and using in this kind of theoretical tools to study different kind of systems. So my first stay was in MONOLITHOS, and yes, definitely it was a really amazing experience because it allows me, in this case, to introduce in the market and try to see, as Santiago told, not only the skills that we have developed in terms of theoretical tools, but also in this case, the direct application of our theoretical tools to, in this case, study different kind of materials. So yeah, definitely it was a very surprising and very huge experience. Yeah.
Thank you, Alberto. So we had the position of a researcher who was directly involved in the secondment, which is the main format of staff exchange, staff mobility, which was implemented within the project. I ask again if there are some questions from the attendees or someone who would like to address some specific question or comments to what's emerged from the different speech. If not, I would like to underline some remarks. The project, the CO2MPRISE is going on. Of course, we suffered a lot for the pandemic, as all of world citizens, and being based on the staff mobility, the project had some specific troubles to be implemented. But anyway, we spent our research at our home laboratories during the pandemic period. But fortunately, during for the remaining months, the remaining period of the project, we see that there is the possibility to start again with staff mobility and research exchange during 2020, the remaining months of this year, 2022. I would like to conclude saying that the opportunity which was given to all of us by this project and by the financial support of the European Union has allowed all of us to improve our knowledge and to perform our activities in strong collaboration with many leading scientists in material science and chemical processes on these topics. It was a very successful all of us for the project, the possibility to work all together in spite of all the difficulties which emerged, of course. And we also hope that there will be the possibilities to go ahead with our research in terms of continuing and pushing the basic research we are carrying out, and also to approach the technology transfer of the results that we are carrying out now, taking into account that many topics many of the topics that we are developing now have been selected by the European Union as topics which are the so-called innovation status within the framework of the European Union funded project. So I hope that this conversation, this short meeting has been interesting for people who attended. I warmly thank you all of the people who, all of the speakers who took part to the round table, and all the people who attended the meeting. And of course, I would like to give a special thanks to Maria Beatriz Lapuente and Sonia Martel, who helped us to organize the meeting, and of course to all the researchers who I see are present now and who took part to the project as a seconded staff, and of course who all of them who now are seconded in different seats of the consortium. Thank you again to all of you, and I believe that we can see again in the near future for further meetings online or in presence in the near future. Thank you again, and see you soon.
Goodbye.
Thank you very much.
Bye.
Thank you.